Since the dawn of human civilization, deadly microorganisms have shaped our history in profound ways. These tiny, invisible foes have been responsible for some of the most catastrophic events in human history, starting with the ancient plagues that ravaged early societies. These plagues were often recorded in ancient manuscripts and depicted in historical imagery, showing the fear and devastation they caused. One of the earliest recorded pandemics was the Plague of Athens in 430 BC. The Plague of Athens struck during the Peloponnesian War, a time of great conflict between Athens and Sparta. This devastating outbreak claimed the lives of nearly a third of the population of Athens, weakening the city-state and altering the course of the war. The impact of the plague was profound, not only in terms of the immediate loss of life, but also in its long-term effects on Athenian society and the broader Greek world. The plague's origins remain a mystery, but its effects are well documented in historical texts. Fast forward to the 14th century, and we encounter one of the most infamous pandemics in history, the Black Death. This bubonic plague originated in Asia and spread through Europe via trade routes, wiping out an estimated 200 million people. The Black Death's rapid spread was facilitated by the extensive trade networks of the time, which connected distant regions and allowed the disease to travel quickly. The plague not only decimated the population, but also caused profound social, economic, and religious upheavals. Entire communities were wiped out, economies were disrupted, and religious institutions were challenged as people sought explanations for the seemingly inexplicable devastation. The Black Death left an indelible mark on European history, reshaping societies in its wake. In the early 20th century, the world faced another deadly pandemic, the Spanish flu. Between 1918 and 1919, this H1N1 influenza virus infected one-third of the global population and claimed the lives of approximately 50 million people. The Spanish flu's rapid spread and high mortality rate made it one of the deadliest pandemics in modern history. Unlike previous pandemics, the Spanish flu occurred in an era of increased global connectivity, which contributed to its swift transmission across continents. The pandemic had far-reaching effects, influencing public health policies and medical practices for years to come. The lessons learned from the Spanish flu continue to inform our responses to modern-day pandemics. These ancient and historical pandemics serve as a grim reminder of the power and persistence of deadly microorganisms. Despite advances in medicine and technology, these microscopic threats continue to pose significant challenges to humanity. Today, we have more tools at our disposal to combat these threats, from advanced medical technology to sophisticated scientific research. However, the battle against deadly microorganisms is far from over. As we continue to explore the realm of these deadly microorganisms, we must also consider the potential threats from beyond our planet. Stay with us as we delve deeper into both earthly and extraterrestrial threats in the next segment. From the ancient plagues that shaped early civilizations to the modern pandemics that challenge our global society, the story of deadly microorganisms is one of resilience and adaptation. Join us as we uncover the secrets of these formidable foes and explore the ongoing battle to protect humanity from their deadly grasp. As we delve deeper into the world of deadly microorganisms, we must confront a terrifying possibility: the use of these microscopic killers as weapons. Bioterrorism, the intentional release of viruses, bacteria, or other germs to cause illness or death, is a chilling reality in our modern world. The concept of using biological agents as weapons is not new. Throughout history, there have been numerous attempts to harness the power of deadly microorganisms for warfare. In the 14th century, the Mongols catapulted plague-infected corpses over the walls of Kaffa, a tactic that may have helped spread the Black Death to Europe. During World War II, Unit 731 of the Imperial Japanese Army conducted horrific experiments with biological weapons, infecting prisoners with deadly pathogens like anthrax and plague. In today's world, the threat of bioterrorism has evolved with advances in biotechnology. The same scientific breakthroughs that allow us to combat diseases can also be exploited to create more potent and deadly biological weapons. The potential for genetically engineered pathogens designed to resist treatment and spread rapidly is a growing concern. Governments and international organizations have implemented various measures to prevent and respond to bioterrorism. The Biological Weapons Convention, a treaty banning the development and use of biological weapons, has been signed by over 180 countries. Surveillance systems and rapid response teams are in place to detect and contain outbreaks, whether natural or man-made. Research into vaccines and treatments for potential bioterror agents is ongoing, with scientists working tirelessly to stay one step ahead of those who would use biology as a weapon. However, the threat of bioterrorism is not limited to state actors. Non-state groups and individuals with access to scientific knowledge and resources could potentially develop and deploy biological agents. This makes the challenge of preventing bioterrorism even more complex and urgent. As we continue to explore the dangers posed by deadly microorganisms, it is crucial to remain vigilant and proactive in our efforts to prevent their misuse. The stakes are high, and the consequences of a successful bioterror attack could be catastrophic. Stay with us as we now turn our attention to the deadliest microorganisms known to humanity, both earthly and extraterrestrial. Could we face a threat that makes even the most fearsome bioweapons look tame by comparison? Keep watching to find out. As we examine the threats posed by deadly microorganisms, we must consider an increasingly influential factor: climate change. The Earth's changing climate is not just altering weather patterns and sea levels, it is also creating new environments where dangerous microorganisms can thrive and spread. Warmer temperatures, increased humidity, and shifting ecosystems are enabling pathogens to expand their habitats. Diseases that were once confined to tropical regions are now appearing in temperate zones, bringing with them new risks to human health. For instance, the Zika virus, once limited to certain parts of Africa and Asia, has now spread to the Americas, causing widespread outbreaks and severe birth defects. But it's not just viruses. Bacteria, fungi, and other microorganisms are also finding new niches. The melting permafrost in the Arctic is releasing ancient pathogens frozen for millennia back into the environment. In 2016, an anthrax outbreak in Siberia was linked to thawing reindeer carcasses, buried in the permafrost decades ago, now exposed due to rising temperatures. Furthermore, climate change is impacting the vectors that transmit diseases. Mosquitoes, ticks, and other insects are moving into new areas, bringing with them diseases like malaria, dengue fever, and Lyme disease. The spread of these vectors increases the risk of outbreaks in regions that were previously unaffected, straining public health systems and posing new challenges for disease prevention and control. Marine environments are not immune either. Warmer ocean temperatures are fostering the growth of harmful algal blooms which can produce toxins harmful to humans and marine life. These blooms are linked to a variety of illnesses, including shellfish poisoning and respiratory issues, posing risks to both public health and marine ecosystems. As we face the dual threats of climate change and emerging microorganisms, it is crucial to invest in research and surveillance. Understanding how changing environmental conditions affect the behavior and spread of pathogens will be key to developing effective strategies for prevention and response. Governments, scientists, and international organizations must work together to address these interconnected challenges. By mitigating climate change and enhancing our capacity to detect and respond to emerging diseases, we can protect global health and prevent future pandemics. Stay with us as we now turn our attention to the deadliest microorganisms known to humanity, both earthly and extraterrestrial. Could we face a threat that makes even the most fearsome bioweapons look tame by comparison? Keep watching to find out. As we delve deeper into the world of deadly microorganisms, it's crucial to highlight the latest scientific advancements that are helping us detect and combat these invisible threats. The race against time is on, and researchers are harnessing cutting-edge technology to stay one step ahead of these potentially devastating pathogens. One of the most promising developments is the use of CRISPR technology. Originally designed for gene editing, CRISPR is now being adapted to detect pathogens with unprecedented speed and accuracy. Scientists are developing CRISPR-based diagnostic tools that can identify specific microorganisms within minutes, allowing for rapid response to outbreaks. This could revolutionize our ability to contain diseases before they spread. Another breakthrough comes from the field of artificial intelligence. AI algorithms are being trained to analyze vast amounts of data from various sources, including social media, medical records, and even satellite imagery. By detecting patterns and anomalies, AI can predict potential outbreaks and provide early warnings, giving public health officials valuable time to prepare and respond. In the realm of combating microorganisms, researchers are exploring the use of bacteriophages, viruses that specifically target and destroy bacteria. These natural predators of bacteria are being engineered to fight antibiotic-resistant strains, offering a potential solution to one of the most pressing challenges in modern medicine. Phage therapy, as it's called, could become a powerful weapon in our arsenal against bacterial infections. Nanotechnology is also playing a significant role in the fight against deadly microorganisms. Scientists are developing nanoparticles that can deliver targeted treatments directly to infected cells, minimizing damage to healthy tissues and enhancing the effectiveness of therapies. These tiny warriors hold promise for treating a wide range of infections, from viruses to fungi. But technology alone is not enough. Global collaboration is essential. International organizations are working together to share data, resources, and expertise. Initiatives like the Global Virome Project aim to identify and catalog every virus capable of infecting humans, creating a comprehensive database that will aid in future research and response efforts. As we continue to push the boundaries of science and technology, the hope is that we can stay ahead of these deadly microorganisms. The stakes are high, but with innovation and cooperation, we have the tools to protect global health and prevent future pandemics. Now let's explore the deadliest microorganisms known to humanity, both earthly and extraterrestrial. Could we face a threat that makes even the most fearsome bioweapons look tame by comparison? Keep watching to find out. As we continue to delve into the world of deadly microorganisms, we must confront a critical question. What are the ethical implications of researching and potentially weaponizing these invisible threats? On one hand, understanding microorganisms is essential for advancing medical science, developing vaccines, and preparing for potential pandemics. The knowledge we gain can save countless lives and improve global health. Yet, as history has shown, this knowledge can also be misused. The concept of weaponizing microorganisms is not new. Throughout history, various nations have explored the use of biological weapons, viruses, bacteria, and other pathogens capable of causing mass casualties. The ethical dilemma arises when the line between defense and offense becomes blurred. One of the primary ethical concerns is the potential for accidental release. Laboratories working with highly infectious agents must adhere to stringent safety protocols, but human error is always a possibility. An accidental release could lead to an uncontrollable outbreak, endangering lives across the globe. Moreover, there is the issue of dual-use research. Scientific studies intended for beneficial purposes, like creating more effective treatments, can also provide the knowledge needed to engineer more potent biological weapons. The challenge lies in regulating and overseeing such research without stifling scientific progress. The potential for misuse by state or non-state actors adds another layer of complexity. In the wrong hands, a weaponized microorganism could be used to target specific populations, leading to devastating consequences. This raises questions about the responsibility of scientists and governments in preventing the proliferation of bioweapons. International treaties such as the Biological Weapons Convention aim to prohibit the development and use of biological weapons. However, enforcement and verification remain challenging. Global cooperation and transparency are essential to ensure these agreements are upheld. Ultimately, the ethical implications of researching and potentially weaponizing deadly microorganisms compel us to reflect on our responsibilities as a global community. Science has the power to protect and heal, but it also carries the potential for harm. Navigating this delicate balance requires vigilance, ethical considerations, and a commitment to the greater good. As we move forward, let us remember the words of the philosopher Albert Schweitzer. Ethics is nothing else than reverence for life. In our quest for knowledge, we must ensure that our actions reflect this reverence, safeguarding humanity from the very dangers we seek to understand. Join us as we continue to explore the mysteries of the microscopic world and consider the profound impact of our choices on the future of our planet and beyond. In recent history, one microorganism has left an indelible mark on the world, the novel coronavirus, SARS-CoV-2, responsible for the COVID-19 pandemic. This case study examines the outbreak and the global response to this unprecedented crisis. The first cases of COVID-19 were reported in Wuhan, China, in December 2019. Within weeks, the virus spread rapidly across the globe, leading to widespread illness and death. By March 2020, the World Health Organization declared COVID-19 a pandemic, and countries began implementing drastic measures to contain the virus. The response to the pandemic varied significantly around the world. Some nations quickly implemented strict lockdowns, social distancing measures, and widespread testing. Others were slower to react, leading to higher infection rates and overwhelmed healthcare systems. The effectiveness of these measures often depended on the speed and decisiveness of government actions, public compliance, and the capacity of healthcare infrastructure. One of the most significant aspects of the response was the rapid development of vaccines. Within a year of the virus's emergence, multiple vaccines received emergency use authorization, a feat unprecedented in the history of medicine. This was made possible through global collaboration, significant funding, and advances in mRNA technology. However, the distribution of vaccines highlighted existing inequalities. Wealthier nations secured large quantities of doses, while many low- and middle-income countries struggled to obtain sufficient supplies. Initiatives like COVAX aimed to address these disparities, but challenges persisted. Public health messaging and communication also played a critical role in the pandemic response. Misinformation and disinformation spread rapidly on social media, complicating efforts to achieve widespread vaccination and adherence to public health guidelines. Governments and health organizations worked tirelessly to combat false information and educate the public about the importance of preventive measures and vaccination. The economic impact of the pandemic was profound. Lockdowns and restrictions led to significant job losses, business closures, and disruptions in global supply chains. Governments implemented various stimulus packages and relief measures to mitigate the economic fallout, but recovery has been uneven. The COVID-19 pandemic also underscored the importance of preparedness and resilience. Countries with robust public health infrastructures and emergency response plans fared better in managing the crisis. The pandemic highlighted the need for global cooperation in addressing health threats and the importance of investing in pandemic preparedness. As we reflect on the COVID-19 pandemic, it is clear that the lessons learned will shape future responses to infectious disease outbreaks. The collaboration and innovation witnessed during this crisis provide a blueprint for tackling future health threats. The pandemic has reminded us of our interconnectedness and the need for solidarity in the face of global challenges. Join us as we continue to explore the mysteries of the microscopic world and consider the profound impact of our choices on the future of our planet and beyond. As we advance further into the 21st century, the future of deadly microorganisms remains an area of intense speculation and concern. While we have made great strides in understanding and combating known pathogens, the potential for new and unforeseen threats looms large. Emerging infectious diseases continue to challenge our scientific and medical communities, with novel viruses, bacteria, and fungi appearing with alarming regularity. One significant area of concern is the impact of climate change on the spread and evolution of microorganisms. As global temperatures rise, previously isolated pathogens may find new habitats, leading to increased transmission and the emergence of new diseases. Melting permafrost, for example, has the potential to release ancient microorganisms that have been dormant for millennia, posing unknown risks to modern ecosystems and human health. But the threats are not limited to our planet. The exploration of space brings with it the potential for encountering extraterrestrial microorganisms. As we send probes and missions to Mars, Europa, and other celestial bodies, we must consider the possibility of bringing back alien pathogens. These microorganisms could be vastly different from anything we have encountered on Earth, potentially possessing unique abilities to survive and thrive in extreme conditions. The idea of panspermia, the hypothesis that life exists throughout the universe and can be spread by meteoroids, asteroids, and comets, raises further questions about the origin and spread of life. If microorganisms can travel through space and colonize new worlds, what might happen if Earth were to receive such visitors? Could they integrate into our ecosystems, or would they pose an existential threat? To prepare for these potential dangers, scientists are developing advanced detection and containment systems. Biosafety protocols for space missions are being rigorously tested to prevent contamination of both Earth and other celestial bodies. Additionally, international collaboration and data sharing are crucial in monitoring and responding to new microbial threats, whether they arise from our changing climate or the vastness of space. As we continue to explore the microscopic world, both on Earth and beyond, the importance of vigilance, preparedness, and global cooperation cannot be overstated. The future of deadly microorganisms is uncertain, but with continued scientific innovation and a commitment to public health, we can hope to mitigate the risks and protect our planet from these invisible adversaries. Join us as we delve deeper into the mysteries of the universe, uncovering the hidden dangers and marvels of the microscopic world. Like, subscribe, and stay curious. There's so much more to discover. Somewhere in the universe, life is thriving in ways we can't even imagine. But among the countless microscopic organisms, one could be the deadliest ever discovered. What is it? And could it threaten life as we know it? When we think of deadly microorganisms, we often picture viruses like Ebola, bacteria like anthrax, or even fungi that zombify insects. But what makes a microorganism truly dangerous? It's a mix of high infectivity, lethal effects, and the ability to spread rapidly. The deadliest microorganisms are those that can do all three. And we might not even know the worst one yet. Life on Earth is just one example of how organisms can evolve. But what about alien microbes? Could a microorganism from another world be far more dangerous than anything we've ever encountered? Scientists believe that if extraterrestrial microorganisms exist, they might be adapted to extreme conditions, radiation, intense pressure, or toxic environments. This could make them unpredictable and possibly unstoppable. We don't have to look to space to find deadly microbes. Here are 3 of Earth's most dangerous known threats. Number 3, anthrax. A bacterium that can survive for decades in spore form and cause fatal infections upon exposure. Number 2, Ebola. A virus with up to a 90% fatality rate, causing massive internal bleeding and organ failure. Number 1, Naegleria fowleri, also known as the brain-eating amoeba. It has a near 100% fatality rate once it reaches the brain, killing its host in days. What if we encounter a microorganism that makes these look harmless? Could we stop it before it spreads? Scientists are constantly monitoring for unknown pathogens, but in a connected world, containment might be impossible. One mutation, one adaptation, and the next deadly microorganism could change everything. The universe is full of mysteries, and some might be waiting to be uncovered. If you enjoyed this journey into the microscopic unknown, subscribe, and stay curious. The universe has many secrets, and we're just getting started.